So last year we ran a couple of resistivity lines early in the year across Capital Gap and across the north end of Snowy River, and they showed that yes, indeed, in this area also we have more hits that may be connected to undiscovered cave passages in that area. But then, but at the end of that period, I fried my old resistivity meter, which meant I absolutely had to get the new one working that I'd been working on for many years. And so in September, we spent the entire week, all of the resistivity time at Cactus Cave. And Cactus Cave dig has been going on. Lee, you first dug into that in what, 68? And have been dug on ever since, off and on. And so the problem is you dig in Cactus Cave and start following the air, and you get into passages where it branches and branches and branches, and the digging becomes harder and harder, and finally lose which direction you're going with the air. So we'd earlier run some resistivity studies in the area, and what they showed was that, similar to a lot of the resistivity surveys up in the Lincoln National Forest, the resistivity hits that we were getting were very, very resistive, much more so than the kind of things that indicate caves further to the north or west. And so no idea what that really means. The other thing is that we got some resistivity lines that indicate that, yes, indeed, the cave is in a resistive area, and along the wash, it is especially resistive. So this is a wash that this is a much blown up topographic map, and along the wash there's a zone of extreme resistivity that we got from a 30-meter line that we'd run earlier up there. And so then later we ran some 15-meter lines in the area, and again got some good hits, got some resistive zones that appear to be going off of the cave. So this time we came back and ran a very detailed grid, what I thought at the time was very detailed, of 5-meter spacings of resistivity lines. And so we ended up running 10 resistivity lines starting on the east and running pretty much north-south, and then running parallel lines 5 meters apart. So I ended up with a really dense grid, 10 by 17 electrodes in there. Then we also came in and ran line crossways to tie all these lines together. So we ran 2 lines, one right by the entrance to Cactus Cave, and one on the north end, and trying to tie all of the two-dimensional north-south lines together. So conventionally, what we've been doing is running 2D lines. You just run a line and analyze it, and you make the assumption, or the assumptions built into the software, that everything to the ends of the earth at right angles to the line is exactly the same. So you're assuming that if you get a hit that looks like a cave, it's a tube that's running at right angles to the line for some distance out to the side. And of course we know that's not true, and side-looking effects on the line affect it, and it's often not clear at all how much those effects really are. So when running the resistivity lines, then this is looking from the east. So you're sitting on the far bank of the stream, looking eastward, looking west at the resistivity lines. Blue in this case is conductive, and so out at the edges here, things aren't really very well defined. So this is kind of the model's guess at what was out there. So what you can take away from this, there's a huge amount of detail, so I'm just going to run through and get the highlights. But basically, off to the far west, even with a cave, it's pretty conductive, and so it's probably shalier sort of stuff. But down at the bottom here, you start picking up something pretty resistive down at about 15 8 to 18 meters. And as you come down the hill, this is line number 9 up on the top. Highest degree, 8, 7. We're stepping down 5 meters at a time, and get down here, and then just north of Cactus, just west of Cactus Cave, we start getting a hit that shows up, and unfortunately, it doesn't show up consistently in some of the other lines. So, guess we're hiding part of it, but this is the line that runs just west of the entrance to Cactus Cave. And so you can see a resistive zone that represents Cactus Cave here. For some reason, there's a pretty strong conductive zone before you see the deep resistive zone yet. And then this line is the one that actually runs right across the entrance to Cactus Cave. And you've got resistive zone that represents Cactus Cave here. You've got a big resistive zone to the south that connects to a deeper resistive thing. And you've got this little conductive blob right there. And John Moses says, well, you got a cave that's reinforced with all kinds of metal and a wire, and you've bolted the ceiling. And yeah, why are you thinking you shouldn't have a conductive zone there? Okay, I'll buy that. So then the next line down the hill, just 5 meters off of the entrance or less, has got a really nice definition of a conductive zone, and it's maybe connected to a big conductive zone off to the south. Now we've stepped further east again, further down the hill towards the wash, and all these slices, by the way, are anchored to the land surface. And off the side, it's getting more uniform, and it seems to be moving north. And you get down to the next line down, it's even further north, and finally the last line that on this end it's right on the wash. On this end, it's about 30 meters, 40 meters above the wash. And it gets here. So you get the general picture of something resistive diagonally across the whole zone. And so then we ran the cross lines, and one of them, this Cactus 9 EW, is the 9th electrode north. So it's the one that runs right past the entrance. And
Can you look at those?
the blue arrows here indicate
The
that
red is more
guys, use your mic. This your mic, please. The blue arrows
Blue area is maybe open.
show where the line
Maybe more
intersected.
Theoretically, would be the dark areas.
So this is where the bottom line came through. This is where the top line came through. And so what we're seeing is right on the very north end of the line, somewhat on the very east end of the line, we've got the convective zone, we've got the cave, and we've got an uphill resistive zone that is sort of ambiguous because we don't have any more horizontal lines beyond north-south lines beyond this point. And the very north end of the line, we've got that nice deep northern section of resistive zone here. And then again, we've got something uphill, but that hasn't really been investigated in depth. Now I'm not getting it to shift now.
Click on the presentation with the mouse first before the remote.
Yeah, if the thing's still in there, let me see it. Let me see this.
That's how it is, all up. Click on the presentation. Here at the end, like.
The bottom thing's still in, isn't it?
Still at the bottom.
Is it still plugged in?
Yeah.
See, can I do it manually here?
Yeah.
How can I
Right
do?
there, this just worked.
Okay, oh,
Yeah,
Working now?
okay, great. Thank you.
back it up to where you.
Okay, so you saw the hits that we got on the north end of the easternmost lines. And so that was looking really interesting. So we went in and ran a set of really short lines with just 2 meter spacing between electrodes on the north end of the lines 0 and 1, the first two on the east. And this is the line 1 just uphill. And you can see that we got a really good hit here. And if you take the average compression, the inflection zone in here, you get a depth of only about 1 to 2 meters to this nice anomaly. And then on the Cactus 0 line, again, it looks a little deeper, but there's a nice hit there. These hits did not exactly agree in horizontal location with the broader space lines, and that's something that seems to be a function of the dipole-dipole system. So, okay, so we ran all of these horizontal lines, we tied them together. We went in and we actually bent the east-west lines, the 2 east-west lines. We bent the ends around. I recalculated all of the scaling factors that you have to apply to the data for those lines, added that into the database. Then we went in and very tediously laid out 2 of the horizontal lines as transmit only lines, and then went in with just a multimeter and collected data from from each of the other lines. And there's for the basically the bottom half, everything from line 5 down to line 0 on the east side by hand. So we got true 3D data. We had dipoles on the transmitter line. We had dipoles on a different receiver line. So now we've got 2D data, we've got cross lines, and we have 3D data for this. So we ended up with a gigantic pile of numbers. It was 8,000 data points in this thing. And so, of course, a lot of them were too far away. I went back, threw out all the most distant data, got it down to 6,000, and then started looking at the scatter in the data. And naturally, these were, a lot of these we were taken by hand. We were trying to speed through it as fast as we could. And so the data is pretty noisy. So it all fits. I mean, it all fits the model pretty well. It's just the size of the halo around the fit line And so I reduced that. We ended up with about 2,500 data points anyway, and put those into the 3D model. The 3D model is a different bird than the 2D model. And so it looks at things differently, obviously in 3D, but also requires different kinds of inputs and limits you in different ways. So anyway, one of the things it gives out is horizontal slices. So what you're looking at here is if you took a strip off the top of the ground between 0 and 1 meter, or this one right here, and here's between 1 and 2 meters. Now the model originally, the 3D model wants to go in and use a scaling factor to adjust the thicknesses of the layers with increasing depth and only give you 6 layers. But I found that you can go in and tell it you have to do 9 layers. And so that's what this is. So I ended them on even layer numbers, which I think makes it a little easier to deal with. So here's the entrance right there. And so right at the entrance is right on the north end of this square. And of course, it's calculating averages for a 5 by 5 meter slab, 1 meter thick. Okay, so you have to keep in mind that, and then it turns around and contours those with the value dead center in that grid. So you can see there's some shifting and distortion that's built into just digitizing this stuff. But anyway, here's the cave. Here's that nice hit to the south that we had been looking at. So then slice it again between 1 and 2 meters. And this is what I wanted to do, just see if we can get an idea of where the heck should we be digging in this cave. And the entrance looks real good. That little blip up to the north that showed up on the cross section sort of shows up here, and we're starting to see some of the deeper stuff get down to 2 to 3 meters now, which is actually right around where we are in the cave, in the deeper parts of the cave. And yeah, we're starting to see it, and it looks like it's trying to bleed off to the south and maybe connect up something here to the northeast. Now, when we get to 3 to 4 meters, we're really 3 to 4.5 meters, we're really in business, because this looks like there's the entrance, there's something pretty conductive running to the southeast, and another arm of it going to the northeast and connecting up to something. And of course, as you go deeper and deeper, it's going to get fuzzier and fuzzier picture. So you're bleeding out. You have to think of maybe something right down the middle of this nice zone that you got here, getting deeper and deeper. But it again shows that structure shifting to the south.
John, you got about 5 minutes left.
Okay, so the other way to look at this is we'll slice it on planes running north south. So these are, you can think of these as slices, like a sliced loaf of bread. Okay, this is the slice between different lines. So the ones of interest here are the ones between lines 4 and 5, and sure enough, cave connection, blah, blah. Okay, and so you can also look at the thing, and normally we look at cross sections from the south. The model insists we look at them from the north, and so again, you get down to where they work your way up from the south to the north, and you get up to this XY plane 8, which is just south of the 9th electrode that's right at the cave mouth. There's that, nice cave. Okay, so another, looking at in comparison to our old data, we ended up, yeah, it fits. You got something off to the north, you got something off to the southeast, And another way of looking at it is the model will take out a block diagram. So all these calculated blocks, and here you're looking at above ground surface from the southeast. Okay, so that red line is above the wash. The wash would be the wash would be a horizontal line here, and cave entrance and cave running off to the northeast. So what are the future plans? We're gonna go back and run a set of lines where there's every 2 to 3 meters and really in real detail, and run where we have maybe a grid of 10 by 10. We'll have to run 17 electrodes, but cross everything, both directions on a 10 by 10 over the entrance for Cactus Cave. I need to pick up an additional way of running the meter, and then later on run additional lines near Elk Creek, where some of the news near where some of the new discoveries are, and also run additional lines up by Pinyon Sink. So many thanks to all the people that worked on the data collection. Very tedious, and I appreciate it a lot. And there'll be more opportunities, or maybe not quite so much tedium next year. Please come help drag wire. Any questions?
Is this on public land? Is this on public land?
It's yes, it is. It's on Fort Stanton reservation. John.
So from memory, it seemed like Newt was challenging us to say, are you sure you're digging in the right spot? And how far you gotta go? And when do we give up?
Those are all the questions that I was running lines to try and answer. I'm sorry to say I can't definitively answer them. That it looks as if we're close to connecting to a cave. The southeast looks like the best way to go. That's about all I can tell you.
You are a wonderful researcher. We're close.
More data is needed.
Oh, we can do one more, but then we gotta keep moving. We're almost powered by.
I'm just wondering where the Elk Creek is, what is below Elk Creek?
It's in the Elk Creek Canyon. Yeah, that's where I want
What's below?
What's below us is I'd have to look on the map. We can talk about that. Okay. Yeah.
Thank you.